All right, guys, here we go. Got linear inequalities today. Another thing that you've done some of this before, but it's been a while. So take some good notes. Let's get through this thing. First of all, we're going to graph and use interval notation, which we did when we did domain and range, to describe the following. The first one says x is less than or equal to 5. The way we're going to graph these today is we're just going to make a number line. It says x is less than 5. I'm going to put 5 right here on my number line. Now, because there's an equal to, it says less than or equal to, I'm always going to circle the 5, but if there's an equal sign, I'm just going to shade in that circle, and less than 5 is to the left of that, so I'm going to darken or shade that whole side of the number line. Okay, and that is the graph part. Then it says use interval notation to describe it. Just describe what I shaded. Where did I shade? That arrow goes to negative infinity. You always go left to right on these, or least to greatest. So I shaded from negative infinity up to 5, and because it actually equals 5, there's a filled-in circle. I'm going to put a bracket with the 5. That's the interval notation. All right, for the second one, it says x is between negative 4 and 8. I'm going to go to negative 4 there, 8 there. Circle with the negative 4 with filled in because there's an equal sign. Circle with the 8 is not filled in because there's no equal sign. Shade in between the two. And the interval notation will look like this. I have a bracket with the negative 4 because of the equal sign. I'm going to go to 8. I shaded between negative 4 and 8, so those are the two numbers that go inside my interval. And I'm going to put a parentheses around the 8 because there was no equal sign and the circle is empty. So empty circle or no equal sign, parentheses, filled in circle, equal sign, bracket. All right, solve these inequalities. So now I'm going to give you a bit of algebra to do as you solve. So move the 15 over first. If I move that 15 over, subtract it from the 3, that's going to give me negative 12. Now, one rule that you got to remember from way back is if I'm about to divide both sides by negative 3. Now, the rule with inequalities is if you divide by a negative, you flip the sign in the middle. So I'm going to make that 4. Draw my number line, put a 4 there, shade it in, shade that way. Where did I shade? I shaded from negative infinity up to 4 with a bracket. Okay, so don't forget, if you divide by negative, you got to flip that inequality sign. Second one here, first thing I'm going to do is I'm going to move that negative x over, which makes it a plus x. That gives me 3x minus 6 is greater than 3. I'm moving that 6 over to the other side. If I move that 6 over, it becomes 9. Divide by 3, it's positive 3, so I'm not flipping the sign. So I get x is greater than 3. If I draw my number line, putting a 3 on it, empty circle, going that way. Where's that arrow going? Positive infinity. Remember, your interval notation goes left to right. So I'm going to go from 3 with the parentheses to infinity. And by the way, infinity always has a parentheses. We talked about that when we did our domain and range day. Weird cases, there's a couple of weird cases you got to look out for. Okay, let's take this one on the left first. I'm going to distribute this 2, so make that 2x minus 8. Over here I've got 2x plus 1. Here's what makes it weird. If I move that over there, or vice versa, no matter which way I move it, get a negative 2x there, this is what I get. They cancel. Okay, so I get negative 8 is greater than 1. And here's what you got to ask yourself when you get something like this. You got to ask yourself, is that true? Is negative 8 bigger than 1? Answer is no, it's not, which means there's no solution. Okay, you can't do it. Now, this is the other weird case. Okay, it's got 4x minus 5. Go ahead over here and let's distribute that 4, make it 4x plus 8. Same thing's going to happen. If I were to move that over, that 4x, they go away because there's no more 4x. So I get this. I get negative 5 is less than or equal to 8. The question becomes, is that true? Answer is yes, that's true. And what that tells you is no matter what you plug in for x, it will work, which means if you did shade, if you shaded this, you would shade the whole number line. So I'm not going to make you do that, but what your answer is going to be is everything works between negative infinity to positive infinity. You've known that in the past as, oh, that's all real numbers. Okay, so there's that. One more slide. Compound inequalities. There are two types of compound inequalities. One is called an and one's called an or. And the difference is this: when you have an and, you're going to shade between 2 points almost all the time. Okay, between like that, I'm just going to make up numbers. Like that could be 2, that could be 5. That's where you're going to shade between. They always come together like that. The or, you're going to shade like there's a number here and a number there on your number line. Like those are the two numbers, like 2 and 5 again. You're actually going to shade that way and shade that way. Okay, so the graphs will go apart. And I'll show you these two examples and see if it makes sense. When you solve this, first of all, that's an and. If you don't see a word and it's written all together like that, that's an and, also known as a conjunction. So I'm going to solve all 3 sides at the same time. I'm just going to add 10 to all 3 sides. and I get 6x. Over here I have 24. Over there I've got 6. Last step, I'm going to divide all 3 sides by 6, and I get 4 over here and 1 over there. Okay, and that's all that it takes to solve an and. Now, remember when you graph an and, that answer says x is between 1 and 4. So I'm going to draw my number line. I'm going to put a 1. I'm going to put a 4. Empty circle, filled in circle because of the equal sign. Shade in between. Interval notation is going to look like this, like we've been doing this whole video, 1 to 4. Okay, when it's an or problem like this last one, this is the last one on the video, just hang in there another second or two. You got to solve both equations, both inequalities. So first thing I'm going to do is move that 5 over. 11 minus 5 is 6. Divide by the 3. I'm getting 2. Or, you need to write the or. Move the 7 over. That's going to make that 30. Divide by the 5. That's going to make that 6. So my answers are either less than 2 or greater than 6. Think about that. There's not any numbers that are both less than 2 and greater than 6. That's why the word or is in there. So I'm going to put the 2 here. Less than 2 is that way. Put the 6 here. Greater than 6 is that way. There's the shading. Now, one weird thing about the or, because there's 2 answers here, when you do your interval notations, you're going to have to put 2 answers. So what did I shade here? I shaded from negative infinity up to 2. What did I shade here? I shaded from 6 to infinity. Now, in between those two parentheses, those 2 intervals, I want you to use this symbol. I want you to put a right side up like a U, means union. Kind of means or and is a good way to think about it. It's just a symbol for it instead of actually writing the word. And I like the symbols, and you need to get used to using those symbols because you got some ways to go in math still, so you're going to use that a lot. All right, hope that helps. Hope you got some good notes. I'll see you tomorrow. Can't wait. See you then.